Hi, I'm Andrew. The title of my final year project is IoT-based Tailgating and Intruder Detector. High-rise buildings such as apartments are a popular choice of living in big cities such as Penang and Kuala Lumpur. One of the people concerned when it comes to place of living is security. For apartment, one of the security problems will be tailgaters. Tailgating is a physical security breach which unauthorized persons follow authorized individuals to enter secure compound. Normally, visitors have to register at the guard post then escorted by the residents to their unit. But during peak hours, security might overlook the tailgaters, and RFID card does not keep tailgaters and intruders out of the apartments. The problems statement are as below, where the security guard does not recognize all the residents of the apartments, and current security system lack two-factor authentication in granting residents permissions to enter the apartments. Camera only plays a passive role in apartment security, and the security guards still have to monitor the video streamed. My proposed solution is an IoT-based tailgating and intruders detectors. The system will consist of a web application, a mobile application, and IoT devices. The system is going to detect tailgaters at the entrance and alert security guard via web notifications. The system will allow face recognition and RFID authentication before residents can enter the apartments. The system enables management of residents' data with web applications, and residents can perform registrations through mobile applications. The system will implement cloud services from Firebase and AWS. This is the proposed device placement. The camera will be located near the gate with RFID readers and infrared motion sensors. The gate will only open if there is no outsiders detected. The objective of this project is to detect intruders or tailgaters and alert security guard to increase the safety of the apartments. It is going to ease human tasks in securing the apartments, and the final objective will be design a system that are able to manage the residents' information. There are three main modules, which are mobile modules, consisting of profile module for residents to register and change their personal profile information. The web module will consist of residents' profile management, where the management officer can use to manage apartments information such as living unit, RFID key, and residents. The tailgaters detection module will detect tailgaters and send notification if tailgaters is detected. The IoT module consists of camera module and RFID gate module to control the gate and camera. This is the architecture diagram. The system consists of three layers, which are IoT and client layer, server and database layer, and cloud service layer. The IoT and client layer consists of the mobile client, web client, and IoT devices such as Raspberry Pi, sensors, camera, gate lock, and RFID reader. The server layer consists of a PostgreSQL database and a web server. The last layer is cloud service layer, which consists of Firebase cloud messaging, AWS recognition, and AWS S3 bucket. This is the flow diagram of the systems. At first, a resident is going to scan his RFID card. The system is going to check if the RFID card is valid. If yes, infrared sensor is turned on and wait for the person to pass through. As the person passes through, image is captured. Image is sent to the servers and look for the sign of tailgaters. If there is anyone unrecognizable, the gate will stay shut. If no, the gate will open. The system identifies tailgaters or intruders based on the person count, the face count, and recognized count. Person count is the number of persons detected inside the photos. Face count is the number of faces detected in the photos, and recognized count is the number of persons in the photo that the system recognizes. If the face count is more than 1, meaning that tailgating actually occurs. When the recognized count is 0, there are more than one intruders, there will be no entry record and alert will be generated and gate will not be unlocked. Else, when the face count is equal to the recognized count, meaning that the tailgaters is actually another residence, the entry record will be generated, alert will be generated, and the gate will be unlocked. If the number of face count is greater than the recognized count, we can actually conclude that the tailgaters consist of intruders or residents. There will be still entry record generated, of course with the alert, but this time since there's intruders, the gate will not be unlocked. If there's only a single face count in the pictures, tailgating does not occur. If the recognized count is 0, meaning that the one that is holding the key, using the key, is actually an intruder, someone that is not registered in the systems. No entry record will be generated, alert will be generated, and gate will not be unlocked. If the recognized person is key owners, there will be we can conclude that there is no intruders. Entry will be generated, alert will not be generated, and gate will be unlocked. This is the normal entry situation. And finally, if the recognized person is not the key owners, meaning that the other residents is holding the person's RFID, the entry will still be generated with the alert and the gate will still be unlocked since the person is part of the residence. There is still some constraint. However, the system does not come without constraint. The system will not work as expected with two-way traffic where entrance is used as exit. The face recognition does not work well in dark or dim conditions, and it requires stable internet connections. The system also recognizes face in photos as persons. I'm going to demo my web applications. This is the web application login page where the users, either the admin or the guard, can log in using their username and password. So, the first page you are going to see when you log in is the dashboard. The dashboard consists of the number of pending residents and the number of unreviewed alert. You can also see the latest alert and latest entry. From here, you can access different parts of the systems, which are the alert section, the entry sessions, the residents, the key, the housing units, and the security. In the alert sections, you can see a table with the alerts generated by the systems when tailgating occurs. By clicking on the tables, you can show the detail of the alert. You can see the pictures captures and the face identified. This is the entry sessions. It also has a table that records and or display the entry generated by the residents. By clicking on the table, you can see the detail of the entry, including the image captures and the face of the residents that has been recognized by the system. In the residence tables, you can add in new residents. You can create new residents, edit their information, or submit a different picture for recognition. This is the key sessions where new RFID key can be added, deleted, or updated. This is the house session where the living unit can be created, deleted, or updated. And finally, the security session where new security admin or security guard can be added, deleted, or updated. Now, I'm going to demo the normal entry by residents where the face of the residents is registered in the system. As we can see, the new entry is added into the entry table. When we click on the table, we can see the detail of the entry. We could also see the resident identified in the image. In this demo, I'm going to simulate the condition where the resident is being tailgated by another resident. Since the resident is tailgating another resident, an alert is generated. Now, from the dashboard, we can see that the unrevealed alert number has increased to 1. We could also see that a new alert is available in the pending section in the alert table. By clicking on the alert, we can see the alert detail. We can either check or set the alert as false alert. And finally, we could also delete the alert. After checking the pending alert, we could see the alert in the review section. I'm now going to delete the girls from the resident table so it will be taken as intruders in the next demo. In this demo, since the girl has been removed from the system, it will be identified as an intruder, and the gate will not be unlocked. This is the mobile application used by the residents. So the residents can log in using their password and username. From here, they can view their personal information and make changes to the information. For example, passwords, profiles, and their images. Besides, residents can also register themselves using the mobile application. The image uploaded will be first validated before it can be submitted. As we can see from the dashboard, the pending residence number increment by 1. And we can view the resident information in the residence pending session table. After validating the residence, we can find the information in this table. The impact and benefit of the system includes tailgating activity can be reduced and apartment will be safer. Security guard tasks in securing apartments from tailgaters will be easier. And finally, residence information can be better managed.